Hi guys, today's video is gonna be about speedo settings, as I promised last week. So as you may know, the modern speedos of today are really technologically advanced and they have really high processing power. So to program them or to set them up can be a little overwhelming if you're not familiar with the settings. So today I'm gonna guide you through the different settings that I use for different applications, and how you can change the settings according to different track conditions and depending on what you are trying to achieve with the car. So the easiest way I figured to do this would be to hook up my phone to the car by using the new OTA programmer, which is a Bluetooth device. And I can just show you on my phone step by step the different functions and explain what they do as we go through them. You don't have to use the OTA programmer to connect your speedo and to program it. You can actually use the traditional style program card, which looks like this. Or you can use the previous device, which is the Wi-Fi Express, which connects your phone to the speedo with a Wi-Fi connection. But I can really recommend the OTA programmer because it's a Bluetooth device. It doesn't interfere with your internet connection, which sometimes is through Wi-Fi. So I highly recommend this item. And yeah, let's look at my phone and see what different settings do. Okay, so to start off this process, we first are gonna connect the OTA programmer to the speedo by plugging it in here on the little output on the front of the speedo. We switch it on. See, the LED is on, and we're now going to enter the HW Link app, version 2, on my Android phone, and we can move on to the next step. Okay, so let's start. We've now opened up the Hobbywing Link app, version 2, and it looks like this. And actually we're going to disconnect here first. I'm going to show you how we can connect ESC. So it's this little button here that's gray. It means that the speedo is disconnected. I'm going to click it. And when you first do this, you need to choose if you want to use Wi-Fi or Bluetooth. But in this case, we're going to use Bluetooth. And since we've started the speedo, it's on and the programmer is connected, we can see this device here is called HW. That's the Bluetooth device that we want to connect to. So now this button is blue in the upper right corner, which means we're connected to the ESC. Okay, so this is a G2 2S speedo that I have connected, and it's mounted on my T4 touring car, which is a touring car for carpet racing. So the first thing that I want to do is I want to look for the firmware. So we're going to the firmware. We can see here that we have the firmware version 4.4.09, which is also the latest version. So if you for some reason want to use a previous version, you can downgrade to these two previous versions here. But I recommend using the latest version because that's what works the best for most purposes. Always make sure you have the latest firmware. Okay, let's go back. We can also look in the data log. You can see some data logged from the speedo by the telemetry function, but I personally don't use that, at least not for now. So let's go into parameters. This is where we're gonna change and look for the settings of the speedo. Okay, so now the settings have been loaded here. Up here in this little box here, you can choose the profile. The speedo has several pre-assigned profiles, which you can all change to whatever you like. You can also change the name of these profiles, so you can save all your profiles and just quickly alternate between them in the speedo, depending on what you use it for. You can use it for different classes or different tracks, different motors, many possibilities. So in this case, I've got mine saved as modified. And you can also import or export For example, you can export. If you export as a picture, it turns into a picture of setup sheet. So for example, that's useful for publishing online or for sharing with your friends, or just to keep for yourself as setting data. But what is more useful is to export as a file, which you can do here. You can save your setting as a file, and you can then import this file for later use, or you can even send it to people. So what I'm gonna do here is I'm gonna show you this profile that I have actually inside of the speedo right now. It's the ETS Vienna 2019. So I previously saved this one, and then when I want to use the same setting on different speedos, on more than one speedo, I can just import it from this file here. So I don't have to enter all the setup data again. I just have to click 2 buttons and it's loaded. Okay, so let's look for the parameters. Let's start from the top. We have general settings here. Most people that are watching this, they're gonna want to use just forward and brake for the running mode. This is pretty self-explanatory, but you can choose to set up the speedo with reverse if you want, for club racing or for different types of racing. But for most racing rules, it's not allowed to use reverse, so you're gonna want to use forward with brake. The maximum reverse force, it refers to the speed of the reverse. So you can make it go faster in reverse, but we're just gonna keep that at 25% for now, because we're not using reverse anyway. And the cutoff voltage, you can set this to automatic. It's actually quite useful if you plan to run longer than 5 minutes. Say you want to do longer practice runs and you're afraid of your LiPo getting damaged from the voltage getting too low. Then you can set the cutoff voltage to a safe amount, to a safe value, that the LiPo will not get damaged when the voltage gets too low. But for racing, we always keep this at disabled, so that even if the battery runs flat, we can still run until the very end. The car will not switch off. So for the thermal protection as well as the motor thermal protection, I always keep these at disabled for racing. I personally never had any problems with temperature in my Hobbywing stuff. It's always run pretty cold, and if you have some malfunction or whatever happens, you don't want your speedo to shut off during racing. So I always keep these at disabled, just to minimize that anything goes wrong and that you can finish the run to avoid a DNF when racing. So keep these off. I mean, if you're concerned about the speedo, you can leave them on, but for racing, I always keep them off at disabled. So BEC voltage. This really depends on the servo that you use. For high voltage servo, I recommend running this at 7.4, which is the maximum voltage, because this controls the supply voltage to your servo. And if it's a HV servo, a high voltage servo, you're gonna want to run it at 7.4 to have the maximum performance. But be careful, if you run 7.4 for a servo that's not supposed to be run with 7.4, you can actually burn or damage the servo. So I recommend running a lower voltage. For example, for the BR1 servos that we use, that I use also, is recommended to be used with 6.0. We've tried using higher. It's not a problem for the servo. The servo can withstand the higher voltage, but the issue we had was that it doesn't stay consistent for 5 minutes, because if you set it to 7.4, the battery voltage will actually drop during the run, and it can also affect the BEC voltage supply. So the most consistent feeling was to have this at 6.0. That's why I recommend that for the BR1 servo at least, but you should also keep this in mind for other servos, that it may be inconsistent for the 5-minute run to use a higher voltage than 6.0. Remote off, this is a function which makes it possible to switch off the speedo by pushing the brakes, by holding the brakes for 6 seconds on your transmitter, and you can remotely switch off the speedo, but it's up to you if you want to leave it on or off. I personally don't see any big use for it, but we can leave it on. Sensor mode. This is going to be full censored for most conditions, or at least for the Hobbywing motors that we use, or for most of competition motors on the market. Motor rotation. For 99% of the RC cars around, we use counterclockwise. But if you are using some vehicle which has the transmission built the other way, you need to put this to clockwise. But leave it for counterclockwise, unless you want a strange surprise when you put the car on the track. So throttle control. Throttle rate control is actually a really powerful setting. It controls basically the feel of the throttle. I wouldn't say that it's a punch setting, but it really controls how punchy and how direct throttle feels. So a lower value will make the throttle feel smoother, and a higher value will make it feel punchier, and it will feel more reactive around the throttle. So let's say that for a small indoor track with a 5.0 motor, I usually use between 25 and 30. But for a 4.5 motor outdoors, because the 4.5 has more power output, I usually use 20, just to make the 4.5 motor feel a little smoother. But you can really adapt this according to the track grip and the track conditions. So you can play with it. You can go, I've been as low as 15 and as high as 30. It really depends on the track conditions, but mostly for outdoors I use 20 for the 4.5, and indoors for carpet I use 25 to 30 for the 5.0. And in 12 scale, the 3.5 turn open modified class, I use mostly between 25 and 30 as well, because it's a 1S class, so you'll want the extra punch actually from the bottom end. And for the 6.5 turns blinky class, you will want to maximize this at 30 for the most possible punch and the most possible throttle response. The throttle curve, you can actually set this to be positive or negative exponential, but I always use this as linear. You can set this up on your computer by connecting the program card to the computer with a cable. The same goes for the brake curve, which I'm going to explain about in a bit. Okay, so the neutral range. For 99% of the time we run this at 6%. If you run it at 4, I mean obviously the throttle will feel more responsive around neutral. But it's not really something that you can feel very clearly. I mean, it's a very minor difference. So usually just leave it at 6 and that's it for all classes. And coast is actually a function which works as a reverse drag brake. So if you're running stock with a very long gear ratio, with a very tall gearing, then you're gonna have a bit of a drag brake effect from that. The car is gonna slow down a lot from that kind of gear ratio. So what you need to do is then you set the drag brake to 0, and you can turn on the coast. You can use 0 to 10% as a start and fine tune around there. But it will, when you let off the throttle, it will let the car coast. So basically it's the opposite of a drag brake. And it can also simulate the feeling of brushed motors from the past. Okay, so that's not something I personally use because I don't race stock. But anyway, it's a really nicely engineered function. Okay, so PWM, drive frequency. This basically determines the resolution of the power band. So a higher drive frequency will give you more RPM but less punch. And a lower drive frequency will give you a punchier feel, but you will have to sacrifice some top speed, some RPM. So in general, for stock racing, I would say 2K or 4K would be the advised setting. And even for 6.5 turn blinky racing, I prefer 4K. But for modified touring car, especially for the 5 turn on carpet, I use 8K most of the time. That gives me the best compromise between RPM and the bottom end. But you can go up to 12K or even 16K for a smoother power band, for less punchy feel. But most of the time it's 8K for modified touring car, both carpet and asphalt. The softening value, actually, it's a pretty revolutionary function because it works almost as a traction control. It basically makes the wheel spin go away, or it limits the wheel spin. So especially on low grip racing conditions, this can make you be able to get away with a more aggressive setting than you normally would, but it will just reduce the wheel spin, so you can use more power than you would be in the first place, and without the car getting loose or getting difficult to drive. So the higher the softening, the smoother the car will feel, and the less wheel spin you'll have. So a good starting point is actually 25 degrees. The degrees determines how strong the softening effect is, and the range determines how deep into the throttle the softening works. So in this case it works until 50% of throttle, so halfway to full throttle. And that's a really good starting point for carpet and even for smaller asphalt tracks, 25-50. For 1S racing, for open modified 12 scale, I use a little bit less, normally 20 and 30. And also for bigger outdoor tracks with a 4.5 turn motor, I use usually 20 and 30 as well. But you can fine tune this to your liking. For stock racing, I don't recommend running any softening, and it's sometimes not even allowed. And the same goes for the 6.5 turn blinky class in the 12 scale. Okay, so drag brake. Drag brake is super sensitive for modified racing especially. So basically it means what it is. Drag brake, when you're not on the throttle, drag brake's gonna kick in. So it means how aggressively the car slows down when you're not on the throttle. So 14% is a good starting point for modified, both for carpet and asphalt actually, but you could go down to 12 probably for asphalt racing and around 14 for carpet, because on asphalt it's just a little less forgiving, and you'll also preserve the tire temperature better if you use a lower value. So actually on asphalt it's a couple percent lower normally than it is on carpet, and also because the tracks are bigger, you don't need the car to slow down as aggressively and as strongly as you need to on carpet when you have really tight and twisty turns. So for modified racing, around 12% starting point for asphalt and around 14% for carpet. For 12 scale, for 6.5 turn, normally around between 5 and 8% depending on the track. And for the 3.5 turns class, actually the same, around 5 to 8%. But again, it depends on your driving style, and it depends on your end build timing and your gear ratio and things like that. As I've said last week, a higher end build timing will give you a stronger drag brake effect. And as I've said earlier in this video, a longer gear ratio will do the same. Okay, so max brake force, that's pretty self-explanatory. That's how strong the brake is. Usually I set it at 100% and then I fine-tune my brake EPA on the radio to feel the way that I want it to. Initial brake force, I always set this to drag brake. And brake rate control is basically the same as throttle rate, so it determines how smooth the brake feels. So you can set this to a lower value to make the brake less responsive and not as strong. But usually I run this at 20 to have a bit stronger brake. But for lower grip, or if you feel that your brake is too strong, you can reduce this, and it has a really big effect on the feeling actually. Okay, so the brake curve. You can also customize a brake curve just like with a throttle curve on the computer by the use of a program card and a cable. But I never tried doing that. I always left it at linear. Brake frequency. It determines how strong the brake is basically. So the lower the frequency, the lower the number, the stronger the brake will be. And the higher the number, the smoother the brake will feel. So usually I end up with 1K for touring car. Sometimes for 12 scale I use 2 and 4K. Usually 2 or 4K depending on the grip levels and such. But this also can depend on your brake control, because there's still 3 different ones that you can use. You can use the linear one, which is the recommended one, the standard one. That's the most linear, the most forgiving and smooth setting. You can use traditional, which is a lot stronger, so it's more difficult to control, and you normally need to reduce your EPA on the radio by 15 to 20% more than you would with the linear style of brake control. And then you also have the hybrid one, which means that it's a mix of the two. It's the mix between linear and traditional. And the one that is used, it's depending on the RPM of the motor. So, for example, it will use the traditional one for higher RPMs to make the car slow down faster, and then the linear one for lower RPMs. But I didn't have that much time to play with this. I usually leave it at linear because that gives me the best feeling. I never liked traditional because it's just too aggressive for me, and I was never able to have it work consistently for me, for my driving style. But then again, it depends on your driving style and on your finger. So usually a good starting point is for touring car and 12 scale linear with 1K frequency for touring car and 2 or 4K for 12 scale. If you decide to use traditional brake, I would recommend running 2K with around 20% less EPA on the brake on the radio. Okay, so boost timing. Boost timing means in degrees how much boost is added to the first step of the throttle or the power band that we can determine with either RPM or automatic. When you set it to RPM, you can fine-tune it for the boost to kick in during certain RPMs. So in this case, it's gonna start at 15,000 and it's gonna end at 25,000. That's the setting I use for a 5-turn on carpet. For most asphalt tracks, I use this at 7.5 to 22,500 with a 4.5 on asphalt. But for carpet, the tracks are a lot smaller. You don't need the boost to start as early. You want it to be smoother, so we use a later starting RPM. And I always use RPM as the activation. I never use auto. But if you want to use auto, you can try that, but it's gonna work a lot different, and it's just very convenient to have it at RPM because you can fine-tune it to kick in when you want it to. Okay, so boost timing 3 degrees are gonna kick in at 15,000 to 25,000 RPM. I think that's fairly easy to comprehend. Turbo timing is activated only at full throttle, so to give you the best possible top speed. And obviously this depends on the length of your straightaway, and also it depends a bit on the infield, because depending on the track layout, the turbo is going to kick in the infield if the infield is large enough for you to use full throttle. So we need to not only think about the straight, but also for the parts of the infield where the turbo might kick in. So for 5-turn motor on carpet, usually 28 degrees is a good starting point. For asphalt, for the 4.5, it can be as low as 28, but it can be as high as 40 if the track's really big. Depends on the length of the straight and so on. You really have to check some of my previous settings from different tracks to try and determine what will be the best for your particular track. For 12 scale, obviously for 6.5 turn blinky, we don't have boost or turbo, but for open modified, you actually have to use quite a lot of boost, because for 1S, as I've explained earlier, for a 1-cell class, you'll have a lot less bottom power, so you want to use quite high of a boost. Normally more than I would in touring cars. So between 8 and 12 degrees, it's actually a good starting point. And the turbo, usually around the same as in touring car or a little lower, between 20 and 30, depending on the track size. In 12 scale modified, we're a bit limited by runtime, so you would have to set it to a value where you don't use too much power and you don't finish your battery in the 8-minute run. Okay, so that's turbo explained. Turbo delay. So as I said earlier, when you hit full throttle, when you push the trigger or the stick to full throttle, turbo is going to kick in. You can have it kick in instantly, or you can have a little bit of a delay. Usually for indoor racing, for smaller tracks, I prefer to have this set to instant, because the straights are normally so short that you'll want the turbo to kick in at once. But on bigger tracks outdoor, with longer straights, you actually want this to be either 0.05 or 0.1, which will help the top speed to build up better, and you'll see that you'll have a bit more top speed with some turbo delay than you would with no turbo delay. So the rule of thumb is normally for smaller tracks, instant or very little, and for bigger tracks you can use more turbo delay. But another thing to consider is, let's say you have a big outdoor track with a really long straight, but a really technical infield, or you have an infield where there's a section where you don't want the turbo to kick in, basically. Then you need to set the turbo delay to a little longer, so like 0.15 for example. That way, if you just touch the full throttle at some point in the infield, it will not give you turbo instantly, and it will make the car shoot off and make you miss the line. So it can be a good idea, depending on the track layout, to try a bit longer turbo delay then, so that to make sure that it only kicks in on the straightaway. For 12 scale modified, usually around the same, 0.05 or 0.1 is a good setting for 12 scale modified. Turbo increase rate. So this is basically how quickly the turbo ramps up. So a lower setting is gonna make the turbo ramp up slower. It's not gonna feel as strong and as aggressive, and a higher number will make the turbo feel more powerful and it will kick in faster. So usually a good starting point for outdoor racing with a 4.5 turn for touring car is 18 degrees. It can be as high as 24, usually within that range. For carpet racing with a 5 turn, normally I prefer 24. but it's always within this range for me, 18 to 24. And actually the same for modified 12 scale, between 18 and 24, but usually 21 or 24 will be preferable in modified 12 scale, because you'll have to use less turbo to not overheat this stuff and not to dump the battery, and then it actually works better when you use a bit higher turbo increase rate with a lower turbo value. And the turbo decrease rate, this is sometimes not super clear for people to understand. The turbo decrease rate means that when you're at full throttle and you lift, this is how strongly the car will slow down. But not to confuse this with drag brake, because drag brake affects the whole power band, whereas turbo decrease rate only affects the speed which decreases from when turbo has kicked in. So, for example, at the end of a long straightaway, when you lift, the turbo decrease rate determines how strongly the car will slow down. So normally, I prefer to have this close to instant, not always instant. Instant is the most aggressive setting, and this can sometimes upset the car and it can make you lose corner speed if the track's flowing. If there's, for example, if there's a sweeper at the end of the straight, or if there's a fast section at the end of the straight, you don't want it to be instant. You want it to be 24, 27 or 30. But on a small indoor track, mostly I would use 30 or instant to make the car slow down faster, and that you can have the most possible turn in at the end of the straightaway for the sweeper. Or even if you have a hairpin corner at the end of the straight, then you definitely should use instant. So yeah, I mean, I hope it's all pretty clear. There's a lot of functions and a lot of information, but if you have any questions at all, just again comment or drop me a message and I will try to explain in more detail. So thank you for watching.